Hello, this is Mr. Taylor with Young Engineers Today. This is a quick recap of our webinar from Wednesday the 17th. We were going more in depth on how to use the EV3 robot so that we can be more prepared for our lab. Reminder, we have a lab in Hickory and in Raleigh this upcoming Saturday, the 20th. And there's a lab in Charlotte Tuesday the 23rd. All right, EV3 robot. Little history about it. It's 15 years in the making. It started off with the RCX, which is this robot here, and then went to the NXT, and roughly, give or take, it's about 8 to 10 years before they update a robot. So a lot of popularity has come out of the Mindstorm series. It's great for learning how to program, code and sequence, as well as developing interactive programs, and you can design a lot of cool robots. All right, there's what some of these look like. The one you're using in class in our labs is the education set. As you can see, you can build a series of robots. Out of these, we'll be using the base model, and we'll be doing sumo bots in our lab. So part of the reason why we're doing this is to have you trained and ready on the little simplistic things, as well as you can program some programs at home. We're going to show you how to download the software and actually allow you to program some robots at home, or write the code so you can bring them in and test them. All right, this is the part for everything. We went over the ultrasonic sensor. It uses ultrasonic sound waves. We discussed in the lab what other animals are similar. As many people said bats, dolphins, because they send out sound waves, it bounces back, and they can identify where something is or how far it is as well. That's how these ultrasonic sensors work. They send in one of the eyes, as they put up air quotes for eyes. One of them is a microphone, the other is a speaker, sends out a sound wave, bounces back. An algorithm, which is a large math equation, calculates the distance for how long it takes for it to bounce back. This is a color light sensor. It can detect different colors, different lights, up to 8 different colors. Okay. Gyroscope. I'm really pumped about this. Gyroscope helps use the magnetic poles of the Earth. It can help make very pinpoint accurate turns versus for 45 and 90 degree it has some preset turns. The only catch on it is when you use it, let's say you have your robot and it's facing the screen of your computer when you download it, when you put it on the ground or whatever direction it's moving, it has to face the same way. Okay. Then we have some motors. We have 2 large servos and 1 medium servo. That's an overview. Now, this is the this is the kit that you would buy like at Toys R Us. This is a consumer kit. It comes with a little remote as well as an infrared sensor. Infrared, they use that in remote controls, as well as like automatic sliding doors. Okay. The one thing on here, a lot of specs on the brick, is that it has 16 megabytes. All right. Now this is the inside of an old NXT, but very similar in the NXT. What you realize, this has a memory chip. It has a processor. Okay. It has RAM. Has an LCD screen. So a lot of the technology that you're using, that's all around you, is being put into this robot. Was put into this robot. The servo motors. Servos are really cool because you can program to move in different speeds. You can slow them down, you can speed them up, and a lot of that is due to the fact that it has a rotation sensor in it, along with a DC motor. And typically DC motors, which most of you probably use, you can either turn them on, turn them off, or change the polarity, not the polarity but the voltage, or switch it around and then make the motor turn a different direction. That's it. With all of this and all the variety of gears, you can do a lot more, and that's what makes these motors really special. On the brick, you can do just about everything. You can program easily. You can do data if you have sensors, such as like temperature sensors. You can do like scientific data, as well as you can make observation on all your motors and sensors. The other thing is as battery layout, different levels, and where you get your play. The play buttons where most recent programs have been created. Here under the files, that's where you would go to your file folder, then inside your file folder you would actually find the program you created, and then brick is where you do your brick programming. Different lights represent different things. I'll just let you read that. And then you have all your ports for input and output. You can actually add an SD card. You can do USB. A lot of different features here. Now, these are some of the different brick interfaces: shut, download, battery, start screen. Some of these I shared in our webinar just because I thought they were really cool. When I was creating this presentation, I was just like, I didn't know this was possible. And I thought it was like, it's the nerd in me. And I was like, this is awesome. You can adjust the sleep, you can adjust the volume, all in the brick, which is really cool. You know, favorites list, device list. And the device list is important because you can enable Wi-Fi. If you put a Wi-Fi USB on it, you can also do Bluetooth. So you can find other things that are out there and hook your robot to it. All right, other devices. You can enable Bluetooth. You can change the settings screen. That's under the wrench. All right. Once again, some more specs on the two motors, on your sensors, and their sensors are pretty accurate. Pretty accurate. I mean, they're within a few centimeters, a few degrees, pretty sensitive. All right. We use a rechargeable battery, but you can also use 4 AA batteries. Okay. To those that use the NXT, there's a lot of similarities, but as you can see, the NXT was made in 2006. And they try to keep a lot of the cost and specs on that the same, but just made it a lot better. All right. All right. And that's just an overview of that. We use the cord in class. The USB end goes to the computer. The macro USB end goes into the brick. Okay. This link allows us to download the software. When you go to download it, you have the option of Mac, which is OS X, or Win32, which is Windows, and then you would click on the link there, and then it takes you to download. You would click on download, and then it will download. Okay, we're going to go through the software. You have the lobby, which you can add project, robot missions. Robot missions, open, recent, quick start, news, more robots, and we'll go through that. Okay. The one thing I want to point out, you have the open recent is number 4. The 2 is where you can add new projects. 1 is the home for the lobby. Those are the main ones. Now, here's your lobby. You have your quick start, and under quick start, you have getting started, and these are all videos. Getting started is a video, software overview video, content enter is a video, and I recommend you just watching these. And the user guide is a PDF, and EV3 is a help section. Okay. Then you have news, and news is really cool because you can have all these news updates, etc., etc. It gives you a lot of news that's just about robots and the EV3. Then under more robots, you have a community. You also have a different and more robots where you have to download these, and when you download them, they show you instructions how to build them, as also some sample code. Okay. All right. Now, a little bit more on brick programming. You have a start screen, block palettes, which will show you have a lot of them. You can do new block add by using between, adjust block settings. And these are all the different blocks. So you can access all the sensors and all the motors just from brick programming. To those who do any like FLL stuff, that's a great little technique if you're in a pinch and you're on your board. You can run, you can even save them and delete them. Here's an example of going through this process. Brick program, went up, navigated, found what I needed, got my motors, got my timer, get another motor, get another timer, etc. And I repeated it. Then I went to the play button, I played it, and then this is what the program looked as a whole. All right, we're going to look at the robot educator configure blocks and some naming. Now, when you go to name a program, I want you to notice that the top row here, that is the programming name for the file. Below that is the actual program, and it's kind of like a file folder. The top is the folder, and what goes inside of it is the program. All right. Now, this is for a Mac, but it might be a little bit different on a PC. But most of the time, from using the NXT for years, it's pretty similar. For the file, you have new program, add a program, open project, close project, save project, etc. Edit, you can cut, copy, paste, those are the major ones. Obviously, you can change language. Tools, now you have sound editor, image editor, my block builder. We'll go over my block builder on Monday. Same with firmware, but you have wireless set up here. Sound and image editor are really cool because you can make little videos about your programs and your videos. So like if you take for your portfolio, you can take pictures, short videos of your robot at your lab and your code and make a little demonstration of like how you programmed your robot and what it did. Cool feature. And then obviously the help is the help area. And when you save it, every time you start a new file folder, you have to rename that project. Okay? As you can see, there's an example of rename project. All right. Now you have the programming canvas where you can program the robot, and you also have, like we talked about for science, using like a temperature sensor, barometer, all that. You can do data collection on there. All right, project properties and structures. This is where you can start putting specs in, giving descriptions of your project, and then you can also put film and stuff in. Okay. And then you have the option of a new program, a new experiment, as we went over that. And then I'll leave this up and you can look at it for a second. But this is where you can do a lot of content editing. And you can add pages, icons, etc. And you can see how you have all this multimedia here, where you can add music, sounds. And here's an example of someone added an image from their robotics competition, and they can put the programs in. They can make a very nice looking presentation. All right. Now, the programming, you have the canvas, the palettes, the hard page, the content editor, and we're going to go through this in more detail where we'll finish up next week. Now, you have brick, port view, and available bricks. Now, brick information tells us how much memory we have. We can delete programs, our battery, we can download, we can play here. Okay? The port view, which is really cool, if your robot is plugged in to your computer, you can actually get live sensor readings. Like if you move the motors, the rotations will change. If sensors, if you have light, and you can get measurements for the light. And then this just tells you how it's connected: USB, Wi-Fi, etc. Then let's look at some of the programming. It's all drag and drop. You have your ports, which are on your robot. The letters are for motors, numbers are for sensors. You have your block inputs where you can attach it to something else, and you have your modes, and every block has that ability. And then you can change them, you can alter them, you can either type in the amounts, or you can use a slider or a drop-down click, like that. Okay. And this is an example of loading images and doing some content editing. Now, last night we went over the action blocks, which are the medium motor, large motor, motor steering, move, take, and display, which I encourage you to try these out and experiment with everything we've gone over. And I will see you at the labs. And as always, thank you for being part of Young Engineers of Today. And have a great day. Thank you.